Today I'm using a multi-tab putty so I can quickly switch between our three consoles. We've got the first console's in router 1, the second console's in router 2, and the third console is into the switch. So I'll start off by configuring router 1. So we're in user mode, so we type enable to go into privilege exec, no password. So we type configure terminal, and now we're in global configuration mode. So the first thing we need to do, as always, is give ourselves a host name. So this will be router 1. Second thing we need to do is we need to set up our security. So we want enable secret class, because we're using standard passwords, so we want everything to be the same. Now sometimes if you make typos, the router will go away and try and do things for a few seconds trying to figure what you're trying to type is typed. So the way we disable that is no IP domain -look up. Okay, I need to learn how to type. Try again. So now, if we do a typo, it's not going to go off doing a DNS query. Second thing we need to do is we need to set up our basic security. First of all, we need to set up the console, line console 0, Cisco, login, and then we need to set up our telnet access. We'll use telnet today because it's nice and fast. So 0 to 4, and we press up arrow a few times to save typing, and we're good to go. And it's always a good practice to set up a banner. Our message of the day is a good old throwback to the Linux Unix way of doing things. So banner message of the day, no access. So now we've set up a banner. So I've done the basics: host name, no IP domain lookup, enable secret class, and the security on both our console port and our telnet port. So now let's go and configure our IP addresses on our interfaces. So the first one we need to do is gigabit 1. Actually, let's quickly verify what interfaces we have. So we do show IP interface brief. Okay, we've got 3 gigabit interfaces. So we've based on our diagram, we want interface gigabit 1, and we'll go IP address 192.168.1.1, 245.245.245.0. And then, of course, it's in disabled mode. As you can see, it's administrative shutdown, so we want to bring that up with no shutdown. Then we'll go into gigabit 2, which is the link between the two routers, and we'll give that IP address 192.168.2.1, 245.245.245.0. Now notice here that as interfaces go up and down, the console message is in our way and it's interrupting what we're typing. So what we'll do is we'll just quickly go and fix that. We go line console 0, and the command you want is logging synchronous. Now you watch what happens next time. So when I go back to gigabit 2 and I bring it up with a no shutdown, notice that now when the console message interrupts my typing, it actually is going to return the cursor to the beginning of the line. See, the cursor's back where it is, and we can keep typing and we're not going to lose anything. So let's just quickly check what we have here. Show IP interface brief. Okay, so gigabit 1, 192.168.1.0, gigabit 2, 192.168.2.1. So let's change over to router 2 and do exactly the same thing. So enable, conft, the most important thing of all, is our host name, and then enable secret class, no IP domain lookup, whoops, what we got, line, PTY 0 to 4, password, Cisco, login, line, console 0, oops, it wants us to exit because it doesn't like this command. So exit, no, I went all the way out. That's no good. Let's try again. What's happened there? Line, console, oh, I did console O instead of console 0, never mind. Password Cisco and login, and then we want a banner as well. Okay, so we've got a password, we've got a no IP domain lookup, we've got a thing. Alright, so now we want interface gigabit 1. It's going to be 192.168.2.2. TCP/IP 2, which is facing over to the right. We'll make that 3.1. And a shot. Show up interface brief. And there we go. So we've got all our interfaces on our router configured and ready to go. So if we ping 192.168.2.1, which is router 1, we should get a response. So the first one always fails because of the ARP timeout. So now we've got a response. So let's actually prove that it works. So we got telnet 192.168.2.1, which is router 1. And here's our awesome banner, no access, go away. Password of Cisco and RIN. So now we're on router 1. We'll exit back out of that one. Now, when we do show IP route though, notice that we can only see the networks we're directly connected. So router 2 can only see 2 and 3. We go back to router 1. Router 1, he can only see his networks. So let's just add the most basic routing protocol of all, RIP. So the command is router RIP. And all we have to do is type network. Oops, network, we'll try the word network, 192.168.1.0. Now the most important thing to do to remember when you're setting up a routing protocol is you only ever advertise the networks you own. You only ever advertise the networks you own. You never advertise networks you don't own. So router 1 can advertise 1 and 2. Then we go back to router 2. RIP network 192.168.2.0 and then 3.0. Now, because this is Cisco's implementation of RIP, you'll probably find, whoops, that it's already working straight away. And there it is. So now router 2 can see all 3 networks, 1, 2, and 3. So let's quickly go back to router 1 and check that as well. There you go. Router 1 can see networks 1, 2, and 3. The network is good to go. Now RIP is a great protocol, but we can do better. So let's just go back into our routing process. And let's go to Ospf, because Ospf is an amazing routing protocol. It's much more powerful than .1.0. Now the trick with Ospf though is you need a few extra commands, and I've made a few videos about Ospf. So please go and look at those. But that is the syntax for Ospf. You have to have the network statement and the wildcard mask that's in an inverse and area 0. So notice here that the current RIP got an R and it's got 120 and hop count of 1. So let's go over to router 2 and do the same thing. Whoops. See, no IP domain lookup helped us there. Otherwise, it would have gone away for 30 seconds. Ospf 1 and instance number network 2.168.2.0 000.245 area 0. And see if I can catch it before we get the message. Alright, so now we've added Ospf. So the two routers are now talking to each other. They're doing a few hellos in Ospf, and any second now we should get a message to say that Ospf has found each other. No, maybe not. There we go. Alright, took a few seconds, but now it's done. So now, to the previous route table, we had 3 networks, one of them by RIP, with a metric of 120, sorry, with an administrative distance of 120, a metric of 1. Now look what happens now that Ospf has learned its stuff. The actual route itself has been taken over. It's been replaced with a capital O for Ospf. So it's still the same network, but now instead of using RIP with an administrative distance 120, we're using Ospf as an administrative distance of 110. Now this number here is representative of cost, because this is gigabit, so therefore there's an extra command in Ospf to say, hey look, gigabit, because Ospf is quite old, so it doesn't understand super fast interfaces, so it thinks the cost is 2. So there you go. So let's have a look at some of my favorite commands. So we've got show IP route, we just did that, didn't we? Never mind, we'll do it again just for fun. And then show IP protocols. It's also a fantastic command because that tells us everything about the routing protocol. So which one is this? This is RIP. So it's got all the timers, the interfaces, the networks, and everything like that. And then we've got Ospf. So it tells you our router ID, our networks for advertising, our administrative distance, and it last updated 2 minutes ago, or 1.1 minute and 24 seconds ago. Show IP interface brief, my other most favorite command. Excellent for troubleshooting, make sure everything's working right. Now I don't know if this will work. No, but that's okay. Let's turn it on. See if it works. Turn on. CDP neighbors is an excellent method for troubleshooting. Very, very useful in the real world, but in the simulated environment, not super helpful because we already know that everything's cabled perfectly because I can't not cable it perfectly. But we'll show, let's have a look and see if it's running. No, let's just give it a minute. Okay, looks like CDP is not supported, so that was a waste of time, but never mind. Alright, let's just verify what we've done. So, we have given ourselves a host name. We've set up our enable secret. We have set no IP domain lookup. Should be a hyphen there, that's a bit of an iOS thing. Don't worry about the certificate, that's put there by default. We have, don't worry about all of that stuff. This is the interface. We've set up our 2 interfaces that we care about. We've set up Ospf and we've set up RIP, but Ospf is the one that's really doing all the work. And then there was one command. Notice here, line console 0, password. Ooh, clear text, that's a bit nasty. Let's fix that up. Service password encryption. Now the best thing about this command, service password encryption, is it's retroactive. So if we do show run again, it will actually go back and now it's gone and obfuscated those clear text passwords. So it's not truly encryption, it's just over the shoulder encryption. Alright, so we have successfully programmed 2 routers to talk to each other in a simple network. Thanks very much. Catch you in the next one.